This is like the most complicated machines that we have in here. So the big difference between what I just showed you and this is what this table is able to do. So what this is called is a 5-axis machine. What that means, it's got 5 axes of freedom. So it could rotate in 2 axes, and it could move in 3 axes. So the only thing we're missing is a 1X because we have to hold the part by something. Okay? So we cannot have that as a free part. So here we get, again, we start with a block, then we mount, and then we get these gizmos. Yeah, it's actually a pretty interesting cam. So it's a lot of work, a lot of small tools that have to happen, but it goes from this to this. Yeah, these are super cool actually. So this is, again, and this machine is the same thing. These are like the most complicated machines that we have. You guys can come in closer now because this is going to be your room. So just watch your steps here, okay? So this machine, again, it's a 5-axis machine that lets you rotate the part in any rotation, and it can move in 3 axes. Okay? As you can see, it rotates everything. It changes tools, same thing as you saw before. And that's going to machine another feature. To give you an idea, so here's what this is doing. So we come in here, so we finish up the both journals here. We finish up this, then we rotate it, then we drill a hole. We drill another hole, then we orient it this way. So all of these steps happen in one operation, which is a key thing because you're holding a really good tolerance. And this part is done as good as the machine can do it, okay? Because you take the human element out of it where you're constantly flipping it. The power of this machine is actually the fact that it's got 2 tombstones, okay? So one of them that's inside this machine, the machine's working on, and the other one that's outside, this is the outside one, this is where we load parts already. So the machine does not need to stop for you to load another piece in there. It's a huge advantage for us. So when that side is done, you close this door, you tell the machine I'm ready, and when it finishes that operation inside, it will pick it up, it will rotate it, and it will switch it up. So now we're back at that second one, okay? So we have a couple of machines like that, and these are really the production machines that we use for all the brackets, okay? So all that stuff happens here. So here, if you guys want to come in, I'll show you the inside of the machine. So see the difference? That spindle is sitting in this horizontal position. So if you can picture this, right now we'll work in this direction, okay? Every single one of those machines I showed you, this was that direction. That's a huge difference of how the material chips fall out, how we could flush stuff out. Plus it gives us the ability, if you look at it inside, that we can rotate the part. So when we're machining this piece, you can picture this. This is still a solid piece of aluminum on this side. We're able to machine it on this side. Then we'll take that tombstone, rotate it. We're machining it here. Rotate it, machine it in here. Rotate it, machine it on this side. So it lets us get into this part from all 3 sides. Actually, it could let us from more sides, but the way it's designed, it's only needing to reach it from this side, and that side. And we specifically do it in the sequence where these holes get aligned from the same operation. So yet again, we're going back to the same thing. Let the machine do the more difficult part. So the features that we machine in that setup are always kind of synced together. So the sequence of operation is important and how that interact with each other to hold the quality that we need to hold to have these things work, okay? And all these machines that I showed you over there, the tool was rotating. Now in here, what we're gonna have is the material is gonna rotate, okay? So we're gonna take this blank and make it into a gear. I mean, you don't see the gear teeth yet. It will be sent out for gear cutting, but basically this piece will go from here, to here in this machine, okay? And that happens in one operation. So what we're gonna do is we're gonna load the blank in here. It's gonna finish up one side of this part. Then this is gonna come in and finish up this side of the part. So here, we start with a solid piece of aluminum. Then the first op is gonna do this. The second op is gonna drop some pockets, and then we're gonna separate those pieces. So here, if you guys wanna come in closer, here. So this is our typical vertical machining process. We have 4 different types of machines in here. This is one of the simplest types, actually 5 different types. So this is the simplest type where we have the spindle go in and out, and it's just a 3-axis movement. And a spindle, so this is our first operation, so we put a raw material, we load it in a vise, and then it does whatever milling necessary, so it does all of this. Now we still have to reach the pockets here, so then we'll lay this part flat, okay? And then we're gonna do all these pockets, okay? And then as we take these parts in here, it's gonna separate it and it's gonna be all done, okay? And this is what you get, yeah. This is basically what you get out of it. So you can see that 3 steps. See, you got 1, 2, 3, and this is what you get. So it basically turns out to be. Okay, and everything happens in the same sequence, every single machine. Like he was saying, so this is the type of tools that we use. So it's a good variety. I mean, you have some end mills, you have some drills, you have some cutters, you have some slitting saws, you have some face mills, indexables, boring bars, anything you want. Anything. So this, you require most of these things to make anything happen here. Okay. So here, I'll show you some more stuff. This is part of our inspection process. So this is how we make sure the parts are done, to specifications. And obviously this is not one of the photo parts, but we're a job shop. We do custom work for different companies also. So this just validates, validate the part, I guess. And it's going to spit out a report that tells us, how that piece worked out, what corrections need to be made or whatever. And it's pretty high-end stuff in here if it comes to quality. And we picked it up not too long ago just to kind of move ourselves ahead. Yeah, I'm not sure how familiar are you guys with machining. Let's start with that.
Oh, no. 0.
So some know something about it, some really are kind of new at this.
Their son works for DMG.
Oh, so your son works for DMG. Okay, so we're DMG Mori, definitely the house in here.
I only know kitchen appliances.
So you're pulling a random sample off your production line?
Exactly.
Like making sure it's
Actually, in this case, this is a first piece. So from that piece, we're going to know how to adjust the machine. Because it seems like, look, in the ideal world, if we program something and then we machine it, it will come out right. But it's not. Nothing's ideal. So we have to take adjustments for tool deflections. Part that's not being stable. There's a lot of things that happens in the process, and I'll bore you with that story. But anyway, so this kind of validates the first step, in our productions where we set up the piece, we come bring it in here, we validate it, and then we know what corrections need to be made, and we'll check it again, and we'll kind of go back and forth totally happy. And then we'll take sampling rate of whatever that sampling rate is we're comfortable with from previous experience or from whatever we see the part fit, and we'll go with this kind of inspection process. So everybody does create 3D models. So this is a 3D models of a part already. So this is how you begin. And what you do is you tell it what points to pick, but you have to still come up with a process how to do this. So it's not super easy. You still have to, tell it where to look and how to look. And then it will be able to take the data and compare the data. That's what it does it for you. But you have to show it exactly how it's done, okay? But first it starts on the CAD, so I could show you like some models here. So what we do first, we do step-by-step design and create a 3D model, okay? Then what we'll do, we'll print it, we 3D print it, and after we 3D print it, then we'll go ahead and start machining that piece in there. So this is where it always starts, okay? So you generate that kind of model, then it kind of flows through the process, okay? From design, then we're gonna do prototyping, usually 3D printing, then we might do additional prototyping if we need to worry about the strength and stuff like this for testing. And then when we're done with all of this, then we'll go into production.